So recall that the geometric series will converge when the absolute value of r is less than 1. The radius of convergence theorem has to do with the convergence for a power series, and that can occur in one of three ways. The series will converge for all x is the first way, and what that means is then that the r is equal to infinity, where the r stands for the radius of convergence. The second way is there exists a number r that's greater than 0, such that the series will converge absolutely if the absolute value of x minus a is less than r. Again, r is the radius of convergence. And the series will diverge absolutely if the absolute value of x minus a is greater than r, the radius of convergence. And the third way is the series will converge only at x is equal to a. And what this means is that the radius of convergence is equal to 0. So in the first example, we're looking at the summation of n is equal to 0 to infinity of 2 to the n, x to the n times x to the second. So that's the summation of n is equal to 0 to infinity times an x squared, 2 to the x to the n. And this is a geometric series. So the absolute value of the ratio is less than 1. The ratio was 2x. Solving for x, with the absolute value of x is less than 1/2, or x minus 0 is less than 1/2. So the radius of convergence is 1/2. That's the r. And recall from previous sections that the interval of convergence then is from -1/2 to 1/2. The next example is a summation from n equals 0 to infinity of x plus 5 to the nth. That's geometric, so the absolute value of the ratio is less than 1, which is x plus 5 is less than 1. So the radius of convergence is 1. We have x plus 5 is less than 1 but greater than -1. So x is less than -4 and greater than -6, and that's the interval of convergence. The next example is not geometric, but recall that a series will diverge if the limit as n approaches infinity of a sub n term does not equal 0. So to look at the limit as n goes to infinity of the a sub nth term, replacing the value of infinity, we get infinity over infinity. So I have to do L'Hopital's rule. So that's the limit as n goes to infinity of 2 to the n times the natural log of 2 over 1. Replacing in the value of infinity, we get infinity. Infinity is not equal to 0. So then the series, the summation from n equals 0 to infinity of 2 to the n over n plus 1 diverges.